robots. We know that
Live
today
streaming is on.
we know that today when all the world are switching toward the automation, we are here to bring something for you. For that, I pleasure to tell you that we have the two guests who's from the Mascot. I welcome Mr. Kasyap Ramaiya sir. He is working as a robotics and IoT engineers with the Mascot Robotics. He did a lot of projects from Plasma Research Institute, Gandhinagar. We have the another guest, Mr. Rakshit Kheradia. Sir is working as a business development head and the project manager in the Mascot. So, on the behalf of Parul University, Department of Mechanical Engineer, I welcome you, sir. Please come and glance at with your knowledge, sir. Kashyap, sir.
Yeah, okay. So can you see my screen?
Yes, sir.
All right. All right. So thank you very much, Om Prakash ji. Hello and good afternoon, everyone. I welcome you all in this session on collaborative robotics, hosted by Mascot Robotics and Automation Ahmedabad. So I hope I deliver the best content to you, which could be helpful to you in your academics as well as in your professional life. And one more thing, we are going to cover practical aspects only. Okay, we are not going to discuss which is already there in books. Okay. All right. So my introduction, Prakash sir already introduced us. All right. So here is the brief about my company, what we are. Okay. So established in 1989, Mascot CNC Tools and Equipment. That is our parent company. So looking the demand of modern industries and industry 4, we have started a new business venture 2.5 years ago. That is Mascot Robotics and Automation. So we are dealing with industrial robotics projects and industrial IoT projects. Okay. So we have delivered multiple projects to industries as well as we have established a robotic lab in Nirma University. So along with that, we have connected more than 100 machines of industries like CNCs, SPMs, furnaces with IoT systems to measure the OE or equipment efficiency of the shop floor or production system. So our vision is to integrate efficient and safer industrial systems. Okay, to assist industry 4 and to assist the productions. Okay. All right. So these are just visuals of our activity. What we do. The first represents our project, industrial projects. Okay. So it is showing a robot is doing some task with CNC machines. So that is our industrial division. We are into industrial IoT actually. So IoT is basically connecting all the sensors and machines of the shop floor and getting the data. Okay, we store it on a cloud, and with the cloud data, okay, we produce some kind of analytics, okay, which helps industries improving their efficiencies. Okay, again, as our third activity, we are into training. Okay, we train industry persons, okay, or any aspiring one who is willing to learn. Okay, and then we deliver webinars and seminars, okay, like what we are doing right now. Okay, so what is our vision behind this such kind of interactive activities? Okay, we are doing this as a CSR, corporate social responsibility. Okay, again, we want to bridge the gap between theory and practice. Okay, then we also want to solve queries of real industries, like industries. Any person having any query, then we can solve them. Again, we want to see India rising as a manufacturing hub with the integration of modern manufacturing technologies and talented manpower. Okay, right. So before we start, let me tell you guys, robotics is an interdisciplinary approach. Okay, any person from a single a unique engineering background cannot work in robotics field. You must be knowing few basic things of other branches as well. Okay, so mechanical is there, electrical is there, electronics is there. Okay, computer IT is there. Okay, so for example, a mechanical guy is willing to grow in the field of robotics, then he must be knowing PLCs, basics of electronics, and basics of programming, and vice versa. Okay, so this presentation is equally important for all of you. Okay, All right, so these are the content we are going to cover. Okay, so first of all, we will try to know before we proceed for collaborative robots, we will try to know what is industrial robots. Okay, so we will try to know basics of robots. Okay, then some point of focus. Okay, what we are going to learn today exactly. Okay, then we will go through applications of robots. What are the applications? How and why it is used. Okay, then I'll introduce a concept of collaborative robots. Okay, then I'll tell you programming methods of robot. Okay, then I should give you some hints. Okay, to become a competent person in the field of robotics. Okay, and then in the end, I'll suggest you some references or sources to learn robotics. Okay, all right. So let us start with overview of industrial revolutions. Okay, so basically, revolution means changing perception or changing methodology of doing something. Okay, so with reference to industrial revolutions, we are changing the perception of production, the perception of working, and the manufacturing technology. Okay, so earlier we used to use steam engines, okay, and other things for manufacturing purpose. Then we started using electrical motors. Okay, uh, and then in third industrial revolution we invented computers, then PLCs. Okay, so we started using those smart device to to produce our to use in manufacturing process. Okay, so now in the fourth industrial revolutions, okay, we are connecting those devices with smart integration systems. Okay, like we are connecting with internet or with other smart devices, we are doing some manufacturing activities. Okay, so basically we are in the midst of fourth industrial revolution. Okay, all right. So let us try to understand. Okay, what is robot? Okay, so if I can tell you in आसान भाषा में, ठीक है. So आसान भाषा में anything which reduces human effort, okay, is machine. Okay, so let us add two sentence. Anything which reduces human effort and which can be controlled by computer and which runs automatic manner is known as robot. ठीक है. तो ओके, सो इट बिकम्स रोबोट. ठीक है, जो नॉर्मल मशीन्स को अगर आप वहाँ पे कंप्यूटर से ऑपरेट करते हो या फिर उसको कोई कॉम्प्लेक्स टास्क वो ऑटोमेटिकली कर रहा है, देन इट बिकम्स robot. Okay, it can be controlled by external controllers or devices or by internal devices. Okay, so here is the main characteristics of industrial robot. Okay, it works with high speed and high precision. Okay, it's never going to take a rest, it's never going tired. Okay, so those are the benefits of robots. Okay, so now what is industrial robots? Okay, so the simple robot which you design for industrial purpose, it becomes industrial robots. Okay, so few important properties of industrial robots. Okay, it works in automatic mode, it is programmable. Okay, and it is multifunctional. Okay, obviously it's robot, it must be working in automated mode. Okay, then again it is programmable. Okay, you can program the same robot for multiple tasks. Okay, so that is another property. And then it can perform multiple tasks. Okay, in first picture you can see that robot is doing some kind of quality inspection task. In second, it is doing some pick and place task. In third, it is doing welding. In fourth, it's doing something else. All right, so these are the properties of robots. Okay, again, it is widely used in dirty, dull, dangerous, and difficult environments. Okay, so when humans don't want to work, robots can work. Okay, all right, so these are the geometries of industrial robots. So these are the basic five types. Okay, so Cartesian, cylindrical, polar, Scara, and articulated robotic arm. Though, so the last picture, okay, what you see is the widely used robot in industry. It is called six-axis industrial robot. Okay, so it is the share of a six-axis robot is more than 70 to 80%. Okay, so when you go to industry, you will see you'll mostly find this kind of robots only. That is why we are going to focus on the six-axis industrial robots today. Okay, so there are other robots which is used in industries as well, and even we are manufacturer of Cartesian and Scara robots. Okay, all right, so these are the pictures of सिक्स एक्सिस इंडस्ट्रियल रोबोट्स. ओके, हाउ इट लुक्स लाइक. ठीक है, तो आपने शायद कोई जियोग्राफिक्स के वीडियोस में, डिस्कवर में, प्रोडक्शंस में देखा होगा. ठीक है, सो दिस आर द सिक्स एक्सिस इंडस्ट्रियल रोबोट्स. ओके, देन you can see the six axis. Okay, why it is called six axis robot? Okay, so you can see A1, A2, A3, A5 to A6. Okay, there are six axis which rotates, okay, in order to do some particular task. Okay, and in this robots are powered by uh, uh, high torque servo motors. Okay, all right. So now now we know what is industrial robots. Okay, so now let us try to know in which sectors, okay, these robots are used. Okay, so most of you are thinking that it's used only in automobile industries. Okay, so it's not like that. It is widely used in uh, various areas. Okay, like it is used in metal industries, machining industries, automobile, electronics, food industries, pharma industries. Okay, again, it is used in plastic industries, finishing and polishing purpose. Okay, it is widely used in aerospace and defense as well. Okay, then it is also used in scientific research and development. Okay, NASA is also using collaborative robots for inspection of for ultrasonic inspection of a fuselage. All right, so these are the sectors where robots are used. Okay, now what they exactly do in industry. Okay, now we know what are the applications, in which sectors robots are used. Now let us try to know exact applications, what exactly robot is going to do in industry. Okay, so these are some of the tasks, like it does pick and place, a widely used application. Then it is used for material handling. Okay, for assembly task. Okay, it assembles components precisely. Okay, it is used for material removal. Okay, sculpturing is also done by robots. Okay, then it is used for machine tending, loading, unloading components to any machine. Okay, it is also used in packaging and palletizing. Okay, that we'll see pictures of all these applications in the upcoming slides. Okay, then it is widely used in gluing, dispensing, and welding. Okay, welding is also done by robots. Okay, then injection molding. Okay, which is used to produce plastic components. Okay, then you can use it for screw driving. Okay, precise screw driving with a particular torque. Okay, human cannot exactly maintain the value of torque. Okay, but robot can do that. All right, so it is widely used in screw driving as well. Then it is used in lab analysis and quality and inspection purpose. Okay, all right, so these are the visuals of robotic applications. So in the first application, it is doing a palletizing task. Okay, so palletizing means at the end of production line, robot is picking the boxes. Okay, and it's keeping on the pallets. Okay, which is it can be carried by forklifts. Okay, so for delivery or to put it in go downs. Okay, so this palletizing is done very effectively and speedily by the robots. Okay, the second application is welding. Okay, so you cannot imagine engineering industries without use of welding process. Okay, so precise and fast welding is also done by robots. Okay, so that is one of the major application of robot. Okay, again it is doing screw driving. Okay, screw driving, it is used in electronic components or other gadgets. Okay, then in the third picture you can see robot is doing machine tending. Okay, what is machine tending means? It is loading the raw material or raw component to the machine, and it unloads the finished component from the machine. Okay, so a person just has to keep a pallet just near the machine. Okay, and it will automatically load and unload the components. Okay, so this is also widely used application of robot. Okay, in fifth picture you can see a person is using a robot for ultrasonic inspection of fuselage. Okay, so in it is doing in better way. Okay, a human can do errors. Okay, but the robot is not going to do that. Okay, so it will do all the tasks precisely and accurately. Okay, then it is used in industrial welding, automobile weldings, or in you can say assembly purpose. Okay, so there are hundreds of components in car. Okay, when you observe your dashboard or other interiors, okay, you will find hundreds of components. Okay, so it's not possible to install all the components manually precisely by human workers. Okay, so it is done very effectively by the robots. Okay, all right, guys. So we are about to start the main session, okay, of today's webinar. So that is collaborative robotics. Okay, so collaborative robots are basically designed to overcome certain disadvantages associated with the traditional industrial robotics. Okay, so in traditional industrial robotics, a worker or a person cannot go just near to to the robot, or it cannot work in the same work environment. Okay, so there are certain disadvantages associated with the industrial robots. Okay, so now in collaborative robots we have tried to reduce that risk. Okay, so with the help of cobot, a worker and a robot, okay, can work simultaneously in a same environment, okay, on the same table or on the same job. Okay. Okay, so this is the example of collaborative robot. It's a universal collaborative robot, and why we are showing you this robot, because this is world's number one brand of collaborative robots. Okay, Universal is world's number brand in collaborative robots. Okay, again we are also distributor and dealer of this cobot of Gujarat zone. Only. So when you observe the industry 4 wheel, okay, you will find various elements of industry 4, okay, like predictive maintenance, congruent engineering, okay, AI, ML, okay, there are a lot of things associated with industry 4. So out of those things, there is one concept which is called human robot collaboration, okay, which is there. So the concept of collaborative robot is associated with this concept of human robot collaboration, like both can work together. Okay. Okay, so as you can see from the picture, okay, a person is working with robot. Okay, there is no a cage or kind of a protective shields over there. Both are working on the same job. Okay, so you can say cobots are specially designed, or it is intended to interact with humans. Okay, so it was not possible in the traditional industrial robots. Okay, even human can work in close proximity of the robot. Okay, they can work together. So there are numerous safety sensors and settings available, okay, in robot, which makes them safe. Okay, so even if it hits to any person, it is going to stop. Okay, it's not going to harm any person. Okay, so there are different levels of collaboration, okay, that we will see in upcoming videos. Okay, so it is possible with collaborative robots. Okay, so these are the six joints of collaborative robots. Okay, why it is known as six axis robot, you can see from here. Okay, there are six axis, a base joint, a shoulder joint, okay, and there is an elbow joint, okay, then three wrist. Okay, so the six joint rotates in order to do some particular task. Okay, one more thing I want to tell you, that there is specific ISO standard, which is ISO 15066, okay, dedicated to collaborative robot, which came into existence in 2016. Okay, so it was not introduced before 2016. Okay, so this is the recent concept in robotics. Okay. All right. So this slide showing how the market of collaborative robot is growing. Okay. So you can see in 2015. Okay, the market was growing by 42%. Okay, and it reached up to 60% in 2019. Okay, so you can imagine how rapidly the concept of collaborative robot is growing. Okay, again on right side you can see the share of various applications. Okay, what we discussed in the previous slides. Okay, like it is used for material handling, painting, pick and place, assembly purpose. Okay, so you can observe the share of collaborative robot in those applications. It is widely used in material handling. Okay, so that is the highest percentage, 32 percentage. Okay, all right. So what are the benefits, okay, we are going to get with the collaborative robots? Okay, so it will convert your shop floor from a blue collar workers to a blue and white collar workers production. Okay, so everybody is going to work together. Okay, ordinary workers can be also upskilled, okay, to operate the robot and to learn the robot and to do other tasks. Okay, so humans will be back into productions. Okay, generally we believe that when we use robots, so we are going to, or many people are going to lose their job. Okay, so it's not true. Collaborative robot in fact increases the job opportunities. Okay, all right. So there is one concept. Okay, like we always used to say, uh, uh, few things cannot be done perfectly by machines, and few things cannot be done perfectly by humans only. Okay, so let us allow robots to do their best task, and let us do our best task. ठीक है, तो मतलब जो काम हम बेटर वे में करेंगे वो हम ही करेंगे, रोबोट जो काम पर्टिकुलर वे में करेगा वो सिर्फ रोबोट्स ही करेगा. ठीक है, बाय डूइंग दिस थिंग्स we are getting better productivity and better quality in manufacturing. Okay, so that is the main thing. Okay, that is the main advantage of collaborative robotics. Okay, so In one study done by MIT, okay, they people found that when a robot and human works together to produce something, okay, or it works on a same shop floor, on a same table, okay, for a same task, okay, then you can increase the productivity by 85%. Okay, so that is a huge number. Okay, so that is the benefit of collaborative robot. Okay, so now let us try to understand, okay, what are the differences between industrial robots and collaborative robots. Okay, both are used in industries, both are six-axis robots. Okay, so now what is the difference? Okay, so as you can see in this picture, okay, the left one is a traditional industrial robot, and the person carrying a robot on shoulder. Okay, that is a collaborative robot. Okay, so as you can see, the industrial robots are fixed mounted. Okay, it is mounted with a particular kind of grouting, so you can move the robot from A place to B place after installation. Whereas on another side, you can easily relocate the collaborative robot which was earlier installed on one production line. Okay, so you can shift it from A place to B place, from B place to C place. Okay, so that is the biggest advantage of collaborative robot. Okay, again, uh, industrial robot doesn't allow human to interact in manufacturing process. Okay, so if robot is working, okay, a human cannot go in the cell. Okay, if a person goes into the cell, okay, it will stop working. Okay, but it's not happening in collaborative robot. Okay, a person can do the work, a person can interfere in the activities done by robots. Okay, means it can work in collaborative manner. Okay, so that is again a benefit of collaborative robot. Then separation of space. Okay, as I told you. Okay, so traditional robots are kept in a particular kind of cage. Okay, so which occupies more and more space. Okay, so it is not happening in collaborative robots. Okay, it can work in shared space. All right, because we know space is the major issues companies are facing nowadays. Okay, so we must save our space. All right, so the collaborative robot occupies less space. Okay, actually, so that is another benefit. Okay, then basically industrial robots are used for repetitive tasks, or you can say for mass production. Okay, on another side, you can say you can use collaborative robot in case of frequent changes. I mean, not for each and every new component, but you can use it for batch order production. You are going to suppose you are going to produce 50, 100 or 500 components, then you can program the robot for different tasks. Okay, and you can even relocate it according to your requirement. Okay, so that is the major benefit. Okay, then due to various safety fencings, okay, and other restrictions, the cost of industry robots are high. Okay, and it gives the return of investment after a long time. Okay, but it's not in case of collaborative robots. You are going to get your return within 1 and 2 years. Okay, so that is another benefit. Okay, let us try to understand how. Okay, so there are two pictures. The one depicts industrial traditional industrial robots, and the second one is collaborative robots. Okay, so guys, let me clear you. There is certain limitation with payload capacity and reach with collaborative robots. Okay, so I'm not saying that all the traditional industrial robots will be replaced by collaborative robots soon. Okay, so uh, up to now, okay, the company has designed a robot with up to weight of 16 kg payload. Okay, it can lift a maximum of 16 kg weight. Okay, so that is the thing you need to keep in mind. Okay, so as you can see from the picture, okay, there is controller, there is a safety cage. Okay, and an industrial robot needs three-phase power. Okay, then again you need costly integration and applications accessories. Okay, then maintenance is also high in case of traditional industrial robots. Okay, but on another side, in collaborative robots, okay, you just need a simple end of arm tool, or which is also known as gripper. Okay, rest of the things it is required, but it is not that much costly. Okay, as this traditional industrial robots. Okay, so that is the major benefit of collaborative robots. Okay. Alright, so why to prefer cobots? Okay, so little bit in depth. Okay, so it is lightweight. The maximum weight of the cobot is varies between 50 to 100 kgs. Okay, you can set up collaborative robots very easily. Okay, any company can establish a robot and program for the first task within 1 hour. Okay, so it's not going to take so much time. Okay, again, it is compact. Okay, in this slide you can see the controller of a traditional robot looks like a cupboard. Okay, okay. So in collaborative robots, you can see the controller is looking like just a briefcase. Okay, so that is another benefit. Okay, anybody can carry the controller easily. Okay, then again, you don't have to change your production layout. Okay, so you just need a space of 150 to 200 maximum. Okay, so that is the footprint of a collaborative robot. Okay, you don't need more space than that. Okay, that you will see in upcoming videos as well. Okay, and you can easily carry from A place to B place. That is the major benefit. Fast setup, fixed displacement, or fixed deployment. Okay, then again it is collaborative and safe. Women can work. Okay, or anybody can work. Okay, then the major benefit, collaborative robot, it works on single phase power supply. Yes, guys. So in a charging point where you charge your phone. Okay, so the robot can work on the same plugs. Okay, so it works on single phase power. Okay, easy programming. Okay, there are different methods of robot programming, but the most widely used method, teaching. Okay, that is easy to learn and easy to use. Okay, all right, and fast payback, that is another benefit of collaborative robot. All right, so now applications of robots. Okay, so you might be thinking that where to use industrial robots and where to use collaborative robots. Okay, but the applications are same. Okay, you can do the same thing with collaborative robots which you are doing with traditional industrial robots. So like tasks like packaging, palletizing, gluing, dispensing. Okay, then comes injection molding, screw driving, lab analysis, machine tending, assembly. Okay, and quality inspection. All the tasks can be done very effectively with collaborative robots. Okay, all right. So this is really interesting. Okay, uh, few case studies of collaborative robots. Okay, who is using, who is programming, how they are using. Okay, so you will find your answer over here. Okay, so it is used by MSMEs as well as MNCs. Okay, so it's not like that only MNCs are going to use collaborative robots. Okay, any MSMEs even can afford the robots. Okay, so these are the classic examples. Okay, where normal operators are doing tasks with robots. They are even producing things. They are working together. Okay, they are programming. Okay, in the middle picture you can see a girl is even programming the robot. Okay, and you will also find videos of these applications. Okay, so it is really interesting. Okay, you can go through the whole case study, how they integrated robots in their environment and how they are getting benefit of the collaborative robotics. Okay, so you can note down the names of few of the names and you can study those later. Okay, all right. So a few other examples, like a few labs are also using collaborative robots to do some tasks. Okay, again, here is example, Bajaj Auto. Okay, Bajaj Auto Pune is the largest user of collaborative robot in India. So Bajaj Pune plant has 150 collaborative robots. Okay, guys, you can't imagine. Okay, 150 robots are working together to deliver you your favorite bikes. Okay, so as you can see, a girl is working, okay, with the collaborative robots. Robot is doing their task and girl is doing their task. Even they can work in close proximity on a same job or in on a different job. Okay, so possible with that is only possible with collaborative robot. Okay, so that is the main thing. Okay, so now this is something interesting. Okay, you must be thinking, all right, so how to program these applications? Okay, and who programs this application? How programs these applications? Okay, and what you need to learn and what you need to know about robot programming. Okay, so this is very interesting topic. So there are 3 to 4 methods of robot programming. The first one is called teaching. Okay, it is manually programming with the help of teach pendant. Okay, so like we teach our kids ABCD. Okay, you can teach a collaborative robot particular programming. Okay, how? You just have to hold the wrist of the robot and you have to move from A place to B place. For example, you want to program a pick and place task. Okay, so in that, what you can do, you just have to hold the wrist of the robot. Okay, you just need to put it above the workpiece. Okay, then it becomes the waypoint first. Then you need to put down the wrist of the robot. It becomes second point. You need to close the gripper. It becomes the third command. Okay, again you will lift the robotic arm. Okay, and you will position it on the place where you want to put the component. Okay, so all these waypoints, okay, it is actually technically it is called waypoints. Okay, so all these waypoints are stored in the controller of the robots. Okay, and when you execute that program, okay, it execute those commands, it becomes your program simply. Okay, you just have to move robot here and there. Okay, and then you need to play. Okay, you can do these things with teach pendant as well, which you can see in a figure left side. Okay, it looks like a video game, guys. So you can move robot up down. Okay, you can rotate clockwise, anti-clockwise. You can move six axes of robots in order to do your task. Okay, and then simply you have to run the program. Okay, you don't have to write any particular kind of codes over here. Okay, you just need to change physical position of the robots. Okay, then this one is the second method. Okay, this is called programming with the help of computers. Okay, or it is known as interactive graphics based programming. Okay, so in some cases when we are unable to program robot with teaching method, okay, we are not getting the accuracy or efficiency, then we can use this software based simulation and programming. So what we do basically, okay, we simply import the model of robot which we are going to use to do our task. Okay, then we are going to import the component, okay, on which we are going to do a robotic task. For example, I want to do machining on a cylinder block, engine cylinder block. Then I just need to import the CAD file, okay, IGS or step file of those components in one environment. Okay, then in the software environment, I am going to give relative motions. Okay, how a robot is supposed to work and what it is supposed to do. Okay, that I will do in a software environment. Then after doing the simulation, I can simply generate the program. Okay, so again you don't need to write the program or codes over here, or you can generate. Okay, so now the generated program can be transferred to robots via a LAN cable or with a pen drive. Okay, you can simply download this program on your pen drive. Okay, and you can run on your robots. Okay, so this is another method of programming, guys. So let me tell you, in between your biggest surprise, this teaching method, okay, which is the simplest one, is widely used. Okay, almost 60 to 70% tasks can be programmed with this teaching method. Okay, that is why simple operators are also using this robot, so they can program the robots. Okay, all right. So this one is the third method. Okay, this is called scripting. Okay, so here's the role of computer IT comes. Okay, every robot has their own programming language, basically, due to uh, some considerations. Okay, but the base of programming is C itself, C language. Okay, and Python. Okay, if you know basics of C and Python, then you can program any robot. Okay, guys, you can easily learn the programming. So this method is also used for some complicated applications. Okay, so this one is the third method of robot programming. The one is teaching, manually teaching, thus holding the wrist and moving here and there, and then you will run the program. In the second method, interactive graphics based programming, okay, you are going to import robot and your components, and you are going to generate the program. Okay, and in third method, okay, you have to write the codes. Okay, all right, so here is an example. As I told you that robotics is an interdisciplinary approach. So how exactly? Okay, so here is an example of machine tending applications. Okay, so what's happening? Okay, there is a CNC machine. Okay, there is one robot. Okay, there are components. Okay, raw materials and finished components. Okay, so what we are doing? Okay, so now mechanical person will design the base of the robots, the gripper of the robots. Okay, the tables, okay, pallets for the robot. Okay, then computer IT person is going to program this robot. Okay, whenever required. Okay, then a person having electrical background, okay, it can program PLC. Okay, again, to do this task, okay, you need to design mechanical components. Okay, you need to program the robot, and you need to connect the robot with the CNC machine. Okay, it's not like they are both working independently. Okay, they are working in a particular manner. Okay, so the PLC of robot interacts with the CNC machine as well. Okay, like it gives signal to the CNC machine like if the component is finished or not, or they have to open the door or not, or whether they have to move or not. Okay, so that is why role of all engineers is there in programming the robots. Okay, so now these are few hints. Okay, how you can gain knowledge in the field of robotics, or you can grow in the field of robotics. Okay, so the first thing you need to do is you need to make yourself familiar with the applications of robots. Okay, so when you see the applications, you will realize, okay, what could be your inputs, what you can learn on, and what you can do exactly. Okay, so I insist you to go through the industrial case studies. Okay, guys, doing projects on Arduino, Raspberry Pi, that's good. Okay, you'll get the benefit. Okay, and you know the fundamentals. Okay, but it's not used in industries. Okay, and on wide base. Okay, so you need to learn industrial applications. Okay, then try to learn C programming, okay, as it is widely used in robots, okay. C and Python, if you can learn, that's very good. Okay, you must be knowing basics of electronics, okay, like we learned in physics or in other subjects like AND gate, OR gate, NAND gate, NOR gate, those are the things. Then you must be knowing basics of PLC, guys. It is, believe it is really useful. Okay, it's not like you have to do PhD on PLC or 6 month of 12 month of course. You must be knowing the basics. Okay, how input output works, how it is connected. Okay, and then what is ladder logic. Okay, so this is really going to help you. Okay, then you can use free simulation tools. Okay, so what we show in the programming window. Okay, interactive graphics based programming. Okay, so it can be done in one simulation environment. Okay, so there are two softwares like there are a lot of softwares, but these are the famous. You can use VBots and Robotic. Okay, VBot is an open source robot simulation platform where you can simulate all types of robots, including collaborative robots and other industrial robots. Okay, so that is freeware. Okay, the second option is Robotic. Okay, that is also a fantastic software. You can avail 1 month of free trial. Okay, so you can learn a lot of things over there as well. Okay, and the most important, you can go with online training, free online training, which is available on our website. Okay, which is universal.robots, universal hyphen robots slash academy. Okay, so you will learn programming the robots in graphical manner. Okay, they will conduct a beautiful training with collaborative robots. Okay, and you can also avail kind of hands-on training. Okay, if you can manage. All right. So these are the ways to keep yourself updated and to prepare yourself to enter in the robotics field. All right. So this is just a screenshot of Universal Robot Academy where you can sign up and learn free robot programming, guys. Okay. So this is the best way to use your period of lockdown. Okay, guys, and the people are even giving free of certificates. Okay, so this is the most interesting thing. Okay, then you can use this VBot software. Okay, all right, guys. So now it's time to unbox the robot. Okay, so I'm going to show you how the collaborative robots can be unboxed, can be installed, and can be programmed easily. Okay, so this is the main interesting thing. Okay, just a minute.
Universal Robots has reinvented industrial robotics with lightweight, flexible robot arms. Tasks previously thought impossible to automate due to cost and complexity are now achievable with the user-friendly robots. The Danish-designed robot arms work separately or as dual arms demonstrated here with the UR5. In more than 45 countries, from the small machine shop to the large auto assembly line, Universal Robots optimize production, relieve employees from strenuous or monotonous tasks, and ensure quality control. Setup and programming is a snap. The robot is ready to go to work within an hour. All the robot's actions can be controlled and programmed through the intuitive touchpad, or by simply guiding the robot arm, showing the desired path of movement. The robots pay attention to detail. Utilizing their 6-axis joints, Universal Robots can handle even the tiniest parts in production processes not practical for manual labor. Employees can work right alongside the robot. If a person comes into contact with the robot arm, it automatically stops operating, ensuring worker safety. This enables you to integrate the robot right into your production with no need for safety guarding. 80% of current Universal Robots applications operate with no shielding. The feature Advanced Force Control makes it possible to adjust the force of the robot to any application. The robot is with you long-term, but your return on investment is short. The payback period is usually between 3 and 8 months for a robot giving you unrivaled performance. For more information, please visit our website.
All right, guys. So hope you enjoyed the videos. Okay, so you must have realized how it is easy to unbox the robot, how it is easy to integrate it, okay, to install it, how it is easy to program, okay, for a task, and how safe it is. Okay, so this was few things. All right. So now we are done with our presentation of today. All right. Thank you very much, everyone. So now we have few minutes, okay, for any question answers. If anybody can, Om Prakash sir, yeah.
Uh, Yeah. Thank you, sir, Kasyap sir.
Yeah, thank you.
Now, yes, I would like to request we have Harish sir here. Harish sir, Harish sir.
Or you can send us mail of your questions, sir, even.
Okay, okay, definitely.
Okay,
Sir, I have one
yeah,
query
yeah.
for the nuclear plants. How are this robot is going to be work for the nuclear plants?
Okay, but first of all, we need to decide the application. I mean, at which place we want to use. Okay, so obviously it is safe. Okay, and it can work in collaborative manner. Okay, and you can integrate other vision systems. Okay, inspection system. Even you can add seventh axis. Okay, so seventh axis, by adding the seventh axis, you are making it movable. Okay, so it moves like AGV. Okay, so like a robot is mounted on the nuclear plant. So if you can develop some systems, okay, which is more secure for
Uh,
those plants, okay, you can go for this
yes.
for those things.
Yes, I want to add few comments on this question. Am I audible to all? Hello?
Yes, 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 yes. Say, sir.
Yes. So your question on how these robots are helpful for nuclear plants and how on such activities.
Yes.
So yes, these robots can be mounted on AGV robots. Okay, those can be controlled remotely from remote locations, and we can do any tasks that we want. And recently, this collaborative robot is used in such a manner and helping in foreign countries for corona patients inspection, trying to monitor their heartbeats. Kashyap, do you have a link of that video? Then you can share how this universal robot is mounted. And this application was developed by
Yeah.
universities in Japan. So
Okay.
yes, I would also like to add one more point. All these technologies are having some roots lied in the universities itself. University guys build such types of research applications, and they make it possible for our nation, for human beings to make our life easy. Yes, there is a YouTube video available where these robots are right now doing sanitization to various applications.
Okay, okay. Thank you, sir. We have Mr. Harish Devjani, sir. Harish, sir.
Yes, sir. Am I audible?
Yes.
Sir,
Yes, sir. I just wanted to ask you this particular thing that what can be the applications of collaborative robotics in the field that we are in, specifically talking about teaching learning experience of like
Yes.
university students.
Yes. See, I would like to answer this question very precisely. Recently, in Ahmedabad, well-known university has developed the collaborative robot lab. We have helped them to develop it. So, how it is useful to universities like you? The point is, uh, these robots are safe. Okay, so students can learn in whichever manner they want. So there are no any self defenses required, because students can during at a time of learning, if any accidents happens, it's a very critical and sensitive issue. So these robots are safe. You can build pick and place applications. You can teach them how to do these programs. And on advanced level, let's say an IT students can do some scripts programming based on Python languages, C languages, and they can develop some applications. If you visit to Universal Robots website, UR Plus products. So in that products, there are many extra accessories developed using some typical softwares. So those softwares are programmed and helpful to make some complex applications. For example, there is one unique feature in this collaborative robot. While doing assembly, robot does a search and go. So if there is a assembly, let's say a camshaft in an engine, so it will search in all 360-degree, and it will push slowly. Then again, it will search, push slowly to the hole, or an assembly. So those types of applications are built using advanced scripting programs, and that can be done by you guys. So those are the applications. And again, there are many protocols like Modbus communication protocols. So those types of protocols can be used to do remote programming. So that's why we will share you one link that the Japan University has used some type of complex programmings using scripts, and they have made this robot to do some sanitization work and mobile. You can say a mobile robot as well. So that way you can build one small lab. Yeah.
Okay, okay. Thank you, sir. Thank you so much.
Even sir, you can do R&D with operating systems as well. There are various softwares available for open source robotics programming.
Yes.
You can
Kashyap, can
use.
you show the last two slides?
Yeah, yes, just a minute.
Uh, yes, I would like to focus each and every individual participant on 35 and 36. Yeah. Yes, go to 35. Yeah. So look at this page. Universal Robots is providing a free training session. It's a 1.5 hour training session. Okay. You all can visit this and you can achieve one small certificate. They will teach you how these robots work, and they will try to give you few of sensitive points on how the cobot works, or how 6-axis cobot works. So you can use this lockdown phase and learn that part. That is totally free of cost, available. And the second one is VBot. Can you focus on 36? Yeah. Believe me, worldwide VBots is used to program any engineering robotics projects. You can do any type of controlling. You can also say Tata group is using this, NASA group is using this. So these types of simulation, and especially I'm focusing on free open source, where you can learn and develop some applications. Not even this, but also your academic projects, where students are building their four-wheel articulated robots. If I give you an example, a Mars rover application, so those types of robots are simulated using these types of simulation softwares. So I think that is the best point in today's webinar, which I am sharing it with you. Okay.
Okay, sir, we have one more faculty from our department, Professor Sohil Siddiqui, sir. Siddiqui, sir.
Okay.
Professor Siddiqui, sir. Okay, I think we are not able to make it connect right now. Uh, okay, sir. It's really a very worthful session with you people. Really,
Yes.
the students are really going to begin a lot, even though your fee faculty are still, the learning a lot here. Thank you very much for this sort of session, sir, and definitely it will helpful for us. Thank you, sir.
Thank you very much.
Okay.
Okay,
Thank you very much.
okay, sir. Thank you. Good day,
Yeah.
sir.
We wish everyone a best of luck for the future.
Okay, sir.
Yeah.
Thank you, sir.
Yes.
Thanks a lot. Yeah.
Thank you, sir. Thank you. Good day, sir.
Thank you. Thank you, everyone. Yeah.
Okay, sir.